is Miss Plant's video where I'm going to be explaining forces and elasticity for AQA Combined Science and Physics GCSE in most likely less than 5 minutes because it is quite a short topic. So, forces can cause objects to change their shape. The change of shape could be compression, stretch, or a bend. If it's going to be a stretch, you're going to have two forces acting on the object, opposite directions acting outwards, compress acting inwards, and a bend, you need to kind of fix your object and have another force on it. For all these three shape changes, more than one force is needed. If you just have one force, the object will most likely change its velocity instead of changing its shape, or the object will move away. These changes of shapes are called deformations. An elastic deformation is when the object will return to its original shape, so an elastic band or a spring. An inelastic deformation, when the object does not return to its original shape, the object has been permanently changed. If you're to crush a can or squash a bit of Play-Doh or something. Now, the rest of this is about springs. So a deformation that causes largely elastic. Now, when you stretch a spring, you stretch it and it will go back to its original shape. However, if you stretch it too much, you probably know the spring will not go to its original shape. It'll become permanently deformed. There's an equation that we can use for the first bit. So before the spring has become deformed. So that's force is spring constant times the extension. I've put all compression here because it could be compressing a sponge. It'd be the same kind of thing. Or it could be compressing a spring if it's a kind of a suspension type spring. You could be compressing it. The extension is the extended bit of the spring, so only the bit by which it's got longer. So usually the kind of length of the spring with the force acting on it minus the original length. Force is equal to spring constant times extension. Spring constant is given K, extension is E. Force is measured in newtons, spring constant newtons per meters, and the extension is measured in meters. Now, this equation tells us that force is proportional to the extension, as in you double the force, you double the extension, you triple the force, you triple the extension, but only up to the limit of proportionality. So if we were to plot this on a graph, and it's best shown on a graph, we put force on our y-axis, extension on our x-axis, and this is probably something you've done because it's one of the required practicals. As you increase the extension, you increase the force, and the first section of the graph is linear. Force is proportional to extension. A straight line through the origin means these two things are proportional for them. However, the graph stops being linear, it becomes non-linear as it curves. The point at which it curves is the limit of proportionality, and you need to be able to kind of point that bit out and say what it means. And that means force is no longer proportional to extension. Your spring has been deformed. It's not going to go back to its original shape. Now, we can find the spring constant from this linear section because force is KE, so force divided by E is K. So force divided by E is the same is this y value divided by the x value, which is the rise over the run, which is the gradient. So the gradient of this linear section can be used to find k, but to be honest, you can just pick off a value for f and a value for e and divide them by each other, and that will give you the spring constant from the graph. Bigger spring constant means you have a stiffer spring, more force needed for the extension. A smaller spring constant means it's a looser spring. Now, the work done on the spring is equal to the elastic potential energy stored in the spring. We can't use work done as force times distance to calculate this elastic potential energy, though, because the force is not constant. If you imagine pulling a spring, it's easier at first to pull the spring, but then it gets harder. So the force is not constant. So we have to use a different equation. This equation you're given, you just have to be able to rearrange and use it, which is not necessarily easy because of the squared in there. But this equation, elastic potential energy, is 0.5 times spring constant times extension squared. Elastic potential energy, given the symbol big E, subscript little e, capital E, subscript little e, measured in joules, 0.5. Spring constant is newtons per meters, and extension is measured in meters. And like I say, you're given that on the physics equation sheet. That is all.